The final seconds now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff. Liftoff of NOAA's GOES-T, our newest weather sentinel in the sky to help keep us safe here on the ground.
Gerald, let's listen in as we listen to United Launch Alliance Rob.
This look good.
Who's the flight mission commentator?
View has gone to closed loop control. The RD-180 is now throttling down as expected. Engine response looks good. We are now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
Max Q, 48 seconds.
We have passed through Mach 1. Vehicle is now passing through max Q, maximum dynamic pressure.
Throttle back those RD-180s.
Now 55 seconds into flight. Atlas is 7 miles in altitude, 4 miles downrange distance, traveling at 1900 miles per hour. RD-180 is now throttling back up.
They backed off the throttle to reduce
Now at
the stress
75
of the
seconds
rocket.
into flight, Atlas is 13 miles in altitude, 10 miles downrange distance, traveling at 2700 miles per hour. Now at 90 seconds into flight, ULA's Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second.
In 10 seconds, those solid rocket motors on the side will cut off. Beautiful shot from space.
SRBs have burned out as expected, and we see a good SRB jettison.
Clear shot of those
Vehicle is now
SRBs.
executing closed loop steering.
Here in a few seconds, they're going to throttle back up.
Vehicle performance looks good at this time. Now 135 seconds into flight. The RD-180 has throttled down slightly. Vehicle performance continues to look good at this time. Tank pressures are stable and Atlas booster battery voltages remain in their expected ranges. Now the upper stage is preparing for its use. Centaur reaction control system is now pressurizing to flight levels.
Now they'll jettison the payload fairing, which protects GOES-T at 3 minutes and 30 seconds.
We have just over 1 minute until BECO. We're now seeing the RD-180 throttle limiting to maintain a 2.5 G acceleration limit. Standing by for payload fairing jettison. And we've seen a successful payload fairing jettison.
Good shot of those fairings.
RD-180 is throttled back up now. And the vehicle has reached a 4.6 G acceleration limit and will maintain this level through BECO.
And you're looking at animation now.
We've seen that the Centaur has begun its boost phase tail down sequence.
Booster about to cut off.
And BECO, booster engine cutoff. Standing by for stage separation and a successful stage separation event. We've seen pre-start on the RL-10. And mess one, we have ignition for the first burn. This first burn of ULA's Centaur upper stage will place the GOES-T spacecraft into a parking orbit around the Earth. This burn will last just over 7 minutes.
What a shot there, huh, Mick?
Yeah, that was great. They're able to see all that and listen to Rob Kesselman call that flight. The first stage performed very well this afternoon, and everything's looking good. Those GEMS
Activity on the reaction control system as it begins its periodic firings to maintain thermal control conditioning.
Yeah, those GEM 63s performed well, solid rocket boosters, and RD 180 performed as well. What I really liked was when we saw the payload fairing come off. That was a great shot from the camera. Saw the payload fairing come off, and then most people probably noticed that little half cylindrical come off after payload fairings. Yeah. That was what we call the Centaur forward load reaction deck. Because the fairing, the 5-meter fairing, encompasses both Centaur
as expected
and the GOES-T satellite, there's a load ring that's inside the fairing around Centaur to help keep that 5-meter fairing from flexing. So that's what you saw when you came off there.
I was wondering about
that. And the engine response remains nominal. I just received word from the Trajectory and Performance Group that booster performance was as expected for the booster phase of flight.
All right, we're going to keep an eye on this burn and listen in. But in the meantime, we'll send it back to Megan out at the host desk.
If you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw GOES-T launch from just behind us at Cape Canaveral Space Force Station. And guess what, everyone? I just found out that this was Kevin's first launch.
It was.
How was it?
It was super exciting. Almost a proud moment as an American, 20-year Air Force vet, and to be able to see this was awesome. Absolutely awesome.
Yeah, I'm so glad to be here. It was very fun to watch you react. Like you were like you were like a kid. Like,
like
I have
a
to
kid.
see this. Oh wow, it was great.
Absolutely.
It was great. So what's next for this mission?
Well, the wonderful thing about this, now that we've had a successful launch, we have about 12 days before it actually reaches geostationary orbit. So at that point, that's when we'll start our checkout phase. We'll be looking for the data to come down from the spacecraft to make sure everything checks out, that the images are correct, all that kind of stuff has to work its way through.
And GOES is NOAA's latest weather satellite, as we've said. We've been launching GOES satellites together for nearly 50 years. I mean, there's been so many advancements made in between those times.
There have. And, I like to remind people that, this particular satellite in the series is really an evolutionary step, much like cell phones. Or when we talk about, hey, do you remember when we used to use landlines and rotary phones? Well, think about the leap we've taken from then to the cell phones and the capabilities that we have, much like that with our satellites.
Yeah, I know. I feel safer knowing that GOES satellites are up there.